Thank you for that introduction. And I guess interestingly enough, it's good to be able to show this project finally, because it actually was the first Hogg and Lamb project. It's been going, well, actually it's been going for longer than Hogg and Lamb, but for 6 years. So it's quite cathartic to finally have it here to be able to show. And it's, I guess, starting out, what were the things that sort of influenced the design? When the clients came to us, they already had it in their mind that they wanted a round earth house. Liked the material, and it was something that they asked us to look at using. The site is in Chandler, sort of halfway between Brisbane and Moreton Bay. And Chandler has become the third most expensive suburb in Brisbane, more expensive than Ascot. And what that meant for this project was that in order for the clients to borrow the money from the bank to build the project, the bank required the house to be of a certain size and what would be, in their eyes, a house that they would be able to sell should anything happen and the clients go bankrupt. So this was a house for 2 people. They have an adult daughter who comes and visits from London from time to time. But it was also a brief that the bank influenced and required a minimum of 4 bedrooms. So one of the issues that we had was how to design a house that could be used by other people in the future. So we always had that in the back of our mind. And also how we could make a house that was big enough for the bank that suited the occupation by 2 people on site, which is the way that it's used most often. When we start our projects, we typically come up with at least 2 different schemes. And this was the unsuccessful scheme in this case, was a little donut type plan that had a captured garden on what was quite a large site. So the existing site is 200 meters by 50 meters and sits right on the edge of a remnant eucalypt forest that continues across a number of sites. And the house has been perched right adjacent to the eucalypt forest, just outside the BAL level. That meant that we didn't have to then do anything to the doors and windows. And you can see a few of the things on this plan were that we identified a kind of wall that ran through the house that divided what we were calling the secondary rooms from the primary rooms. And the secondary rooms were really the additional spaces that the bank wanted the house to have from the primary rooms, which were the ones that were going to be used on a daily basis by the clients. This was the alternative scheme that we proposed and the one that they went for. Again, kind of one singular wall that ran through the center of the house that separated a secondary side from a primary side. The secondary side is the approach from the existing driveway on the property, and the primary side is to the north, slightly twisted to face the city and to be adjacent to the eucalypt forest. And this is a shot of the wall during construction that ran through the center of the house, made from obviously rammed earth. And we'd never used rammed earth before. And it's got a few technical challenges that we needed to overcome. One of them is that it doesn't really like getting wet. So whether that's going into the ground or having the top of it exposed when it's outside, or the wall getting wet, are not things that it likes doing. And also, and probably the bigger challenge, is that rammed earth has got great thermal mass, but really not any R value. So what that meant was that the walls, if we were going to use them as external walls, would need to be clad on either the inside or the outside and insulated. And we felt that by going to the effort of making the rammed earth walls that it seemed like a waste to make these beautiful walls and then cover them up in order to achieve the R value. So the idea of running the wall through the center of the house and using it really as a planning device meant that the wall could be exposed on both sides, which would give you the maximum sort of experience of the wall on a daily basis. And then the ability to pass through that wall was something that kept the wall kind of in your mind as you were using the building constantly. The wall plays a role in kind of adapting the scale of the site, which is quite large, to the scale of the human. I can see a few people down here in the back. This is where the floor level ends up being. And these openings through the walls are all 2.1 meters high and quite cozy when you're walking through them. The wall is 400 mils thick. So it kind of really creates a sort of experience where for a short period of time, you're actually sort of feeling like you're inside the wall. This is the way the plan sort of panned out, with the rammed earth wall running east-west. On the approach side of the house is really a collection of rooms that are somewhat secondary, housing extra accommodation for future people or for guest accommodation for now. And really on the northern side of the wall is the primary spaces where the clients currently live, which is almost like a one-bedroom loft apartment on the northern side. Just outside the living spaces is a flat landscape terrace and a swimming pool that is about to start construction, but hasn't happened yet. On the upper floor, again, the secondary spaces, extra bedrooms and bathrooms. Coming through to the main primary side, which is the master bedroom, ensuite, and a big double height space over the living and dining room downstairs. In terms of like passing through the wall, one of the things we've done in plan is that the vertical links between levels is on the southern side of the rammed earth, while the main spaces are on the north. So to travel from the master bedroom to the living spaces, you pass through the rammed earth wall, go down the stairs, arrive in the entry, and then back through the rammed earth wall to get to the kitchen. So the experience of using the house is one of constantly passing through the wall, which again, we thought was a way of getting the maximum sort of value for money from going to the effort of making this rammed earth wall. And this is the kind of experience of that wall on either side. So this is the southern side of the wall, a hallway that links multiple secondary rooms. The clients currently use one as their office, and in kind of recent lockdown have managed to run their business from home, which has worked out quite well. But you get this beautiful kind of orange glowing of the rammed earth, kind of reflects the natural timbers that were used for the floor and the ceiling. And on the left-hand side here is the opening, the main opening through the wall that you pass through when you're coming from the entry of the house into the main double height lounge and dining space. So once through the rammed earth wall, the character of the spaces changes. You're on the side of the wall that opens up with more light. It's double height, and there's a couple of skylights that also graze the wall with light as it changes throughout the day. And this is a shot from the bedroom, master bedroom upstairs, where you can see that the wall passes through the bedroom, then out into the double height living space, and then beyond the house in the distance here. And as it does go outside, there are a few little remnants of the wall that kind of going to degrade over time and end up eventually coming back into the landscape as if it's part of the hill that was eroded prior to this house being built. A few things with the rammed earth that we thought were important. One was that the color, clients didn't want to have a reddish rammed earth wall. So we tried to match both the color of the surrounding soil on site and also match in with the color of travertine stone. So you can see here the color of the existing site and the color of the rammed earth being pretty closely matched. Unfortunately, we couldn't use the soil on site in the rammed earth wall because it had too much kind of organic matter. And what we did do was try to get the appearance of the rammed earth such that it could be mistaken for travertine. And then when came time to selecting the stones, we tried to choose travertine and marbles that then looked like they were rammed earth. By doing that, and also some kind of special detailing that created these square openings, the idea was that there were these blocks of eroded mountain or the eroded hill that used to be the site, that then the house has kind of been built around and then you occupy. So again, the affinity here between the finishes and the rammed earth, so that you kind of see them as a collection of the sort of stone remnants on the site. Another technical concern that we overcame by working quite closely with Rob Lord, the mechanical and ESD consultant, was this wall had 75 tons of thermal mass, which, if it's not sitting in the sun, can be problematic in winter, like sucking out too much heat during the day. So what we've done is we have a series of vertical ducts that run through the rammed earth wall. You can kind of see them coming out at the bottom. And what they do is they connect the roof space in the trusses down into a subfloor ventilation system. And then in winter, on a day like today, when it's blue skies and sunshine, the heat is collected in the roof. All the insulation is put on the bottom, but not on the top. So the roof gets hot, and then slowly the air is sucked down through the rammed earth wall. And that has the effect of heating up the wall slowly during the day, so that in the evening, it becomes the main heating system for the house. And then it does a similar thing in summer at about 4 o'clock in the morning when the conditions are right. It's got a heat conductive paint on the top of the roof that makes the airspace in the roof colder than the air outside. And when that's the case, it starts sucking that roof air down through the wall, slowly cooling the wall down, so that again, the wall has cooled down overnight and it's ready to then start sucking heat out of the space during summer again. On the southern facade, it was very much about trying to be efficient with the budget. Here we have like 2 levels of timber framed FC clad building, detailed in a way so the windows look like they're a 2-story high vertical form. And the idea here is that these are shards of rock that have come up around. Then when we get around to the north, unfortunately, I don't have any great shots by Christopher Frederick Jones, as the landscaping hadn't gone in on his side. But once we're around to the north, it's a different facade system that's about opening up to the eucalypts, controlling the sun during summer and winter to get the maximum amount of heat in when it's required and not. So there's a 2.5 meter overhang there, automatic ventilation through louvers, and you get this sort of very expansive outlook to the eucalypt forest. Facing west, this is a view from the master bedroom that looks back towards the city. we designed this window having been inspired by some James Turrell artwork. And what it does is has a single fixed piece of glass here. And then the plasterboard on the inside comes down to a very sharp setting bead. And the effect of that is that you don't read the depth of the wall here, which is what Turrell does for his artworks to the sky. And the view that's beyond the wall appears to like stick to the wall, more like it's an artwork on the wall rather than a view to the distance. And that has this sort of ever-changing effect on the wall, where the nature and its constantly changing character is like an artwork that's on the wall rather than a view to the distance. There's a lot of sustainability built into the house. And I think something that's interesting is that the aesthetics of a house aren't linked to the way it works sustainably. So it may not look like necessarily a sustainable house, I guess, in inverted commas, beyond the rammed earth, but it's 7.5-star Natters, even without the 75 tons of thermal mass being accounted, because Natters can't take into its maths that kind of system. The plans obviously aligned east-west, maximize cross-ventilation, energy-efficient glass, all LED lighting, 29,000-litre underground water tank. It's got its own on-site septic system where all the waste is then reused for the landscaping, 20-kilowatt photovoltaic system on the roof with provision for batteries, and a whole-of-life kind of plan that enables with the lift and ramps so that it's equitably accessible throughout the life of the clients. And that's probably my time done.